Good morning, everybody. Welcome to today's session. Today we have Jason Fox as your speaker, and he will be talking about NGSI-LD Advanced Operations. So Jason, please take it away.
Good morning, everybody. I hope you're enjoying your coffee early in the morning. It'd be nice to do this live, but hey, we're doing it online. I am going to be presenting for up to 3 hours here. So I want to make this a little bit more interactive. I want to make sure that I'm answering the questions which you actually have. And I want to, if necessary, digress from what I've got and answer questions which you personally have. So before I actually start on my Death by PowerPoint, which is going to be the basis for discussion, I thought I'd share something with you. I received some fan mail. A long-term viewer, first-time caller, and one of the participants was asking me about the various questions on the fireware tutorials, and specifically looking at the fireware tutorial for linked data, which is actually the first linked data tutorial I wrote. So it's got its issues, to be honest. There are things which I've done wrong, I readily admit, but it's a good starting point. First things first, right? When we query context data, and this is when you're querying context data and you are not supplying a linked at context, you get a nice, if you go through the exercise, you get a nice little entity, and the entity has got an address which is being expanded to schema.org address. It's got a category which is being expanded to fireware data models category, and it's got a location in the name. And the question is, why are location and name not expanded? And there are actually two reasons why this might be the case. The first thing you've got to remember is that every NGSI payload assumes that you are applying the core context. And the core context has already defined a certain number of attributes. And it has also got an at vocab directive at the end of the core context. You can look at the core context file online yourself. It's I'm not sure which one this is. This is just a minute. I'll put this in the chat. See, right now, how do I get into the chat? Chat. There we go. Click on that. Why is that not highlight? There we go. Say something, right? So there's one of the core contexts. That's the core context, the original core context. If you have a look at the file itself, at the end, it's got an at vocab which says anything which I haven't already defined, put it into the default context. So when you have a payload, there's the thing gone again. Tab, tab, tab. Which has got something like that, where it says I've got store, I've got schema address, and I'm a building of some sort. If you have keywords which are already defined in that core context, and it'd be great if you actually just click on the first link and just see where it comes up, and you'll find there is a file behind there. It has already defined name. It has already defined location. Location is so fundamental to NGSI because effectively it's always things in the real world, and things in the real world have got places that we need to. If you look at a location, it would look like this. Again, keep an eye on your chat. Look like that, location, because it is implicit in your NGSI payload that you can expand location, you can expand property, you can expand geo property, you can expand type, you can expand ID. Type actually is at type. ID is actually at ID. These are fundamentals defined by JSON-LD. So the reason why it becomes more complex here is that when you are talking about broker-to-broker communication, where you know you're talking NGSI to NGSI, it makes precious little sense to say, oh yes, and you must also put the core context in there, because otherwise nothing will work. So it's implied. However, when you are making a curl request, let's say, or you're a third-party application which is coming up and saying, I want to get hold of some data, if you literally just go for give me the data from the core context, the data from the context broker, without thinking, what is my what is the context file or files I want to use for my system, then what you're going to get out is not valid JSON-LD. Well, it is, but it isn't expandable, because obviously it hasn't got these definitions like property or location or building in it. This is one reason that when and we had this discussion last week, when I would tend to put my core context out in the real world, I would tend to have a core context which has got something along the lines of, and I won't put the, sorry, there's just a bracket, core context, comma, my context, an array where I would have two elements in my context file, both of them linking to other files. Again, you need to look in the JSON-LD definition to find out how you can define your at context file, and that way it's explicit to a third party that I am both reading core context and I'm reading my context, and that means that I should always get short names when I'm using links, and all my data comes out. Now, the other reason why you might end up with a short name in your response is that you failed to place any definition of it into the my context file. And this is because everything falls into the default context of it and nothing else. Not very useful as far as I'm concerned. I mean, obviously practical in that it's able to give you a response, but it's not very useful for data exchange. If you want to offer a third party a temperature, you should really define that temperature using a URL, and it shouldn't be default context Etsy URI /default context / temperature, because that's not going to be a common name. You should actually use whatever the common name mapping for something really is. Now, it's easy enough to ensure that your attributes work this way, because most of the time you're thinking, okay, I've got a building, it's got an address, a blah 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 blah. However, you'll find that over time the number of attributes you have in a system will grow. You'll need to add in additional stuff, and you'll need to keep maintaining this context file. And also, you should also think, well, what about the metadata? What about the properties of the properties, or the relationships of the properties? Have I got something for provided by? Have I got something for accuracy for a device reading or something like that? Because it's not linked directly to the model you have in the real world. Right, so that was the first question I got. This the next question was saying, when I look for the context file on that particular tutorial in at least one of the formats, there are three formats of this tutorial. The context file was pointed to the attributes of the context file, like URI firewall.org. If you click on this link, and I'll put this into the chat as well. If you click on this link, it'll 404. because that's not a web page. It's nice when it is a web page, but it's not essential. You can because you've got to remember that the long names are URIs rather than necessarily human readable forms. I mean, ideally, if the fireware data models had become a more a more mature product, then yes, this would come through to a proper page. But this is the fireware specific version here is deprecated, and we now use smart data models in association with IDSA, TM Forum, etc., etc., etc. There is a more central and neutral place to put these, and therefore more work would be done in that area than actually on the fireware website to actually come up with proper information. If you look at the later tutorials, because I was designing my at context from scratch, I was deliberately put stuff online, which would mean that you could actually go through the links and you could actually see what my little smart supermarket is. I would recommend very much that you put as much of this public as possible so that you are helping third parties to get hold of this information. Now, so where are we? The next question. So I think that covers most of those first questions, but it does mean that at least one of you has started looking at the tutorials, which is good. So I'm now going to ask you your first question. I'd like you to break into various groups and actually think about something. When I created the NGSI first driven tutorials, the NGSI-LD fireware tutorials, the very first thing I dealt with was creating your app context file and creating your models. So what I would like you to do, and so give me a chance to get my breath and get it and have a glass of water, is I would like you to break into groups on the tables in a couple of minutes, and I want you to present an application you are familiar with or you've designed or what have you, saying, like I did last week. I said, I'm a tourist authority. I want to send cyclists out of the rain into various pubs in my local area. So for a system you are familiar with, describe what it is, and then for the other people on the table, I would like you to think and come up with which data models do you see in that particular scenario? Which attributes do you see in that scenario? And this is the hard bit, where would you get the proper URL long names for these entities? So if the host could just break us out for a minute, and I'll give you 3 minutes to think about it, 5 minutes to think about it, and then come back and I'll talk a bit later, because I'd like to get some polling done on this.
And we're back.
Okay, and I'm still on my first slide, aren't I? I'm doing well. You will probably have found, if you are dealing in, actually, I'll get a show of hands. Can you actually just show some appreciation here? Who here is dealing in the smart city sector? Could I just get a reaction emoji? Okay, we've got a couple of people doing smart cities. Anyone dealing with agriculture? Not many, slightly less. How about smart tourism? Oh, got some talk. I'll come in more to that later. How about other sectors like e-health? Now you will. Oh, someone's raised their hand. That's interesting. See what you're doing. Okay, right. You requested. Yeah. Do you want to let Vega come on? Come on, because we might try to get this interactive.
Oh.
You wanted to speak? You want to say something?
Okay. About my model.
Yes. Well, you've raised your hand to come on stage. So I was going to do that next. You will have. I was going to say. I'll just do the introduction. You will have found if you were dealing in smart cities, there are already lots of common data models in smart cities. So this exercise will be quite easy. If you were dealing in smart agriculture, you will find that there are already models in smart agriculture. So that's, again, quite easy. It's much more difficult to come up with data models if you're in tourism or indeed you're in health, because they don't currently exist in the smart data models system. So it's difficult to work out what you've got. So we've got someone who's dealing with health here. What models or entities did you come up with as you would like to have modeled in your system?
Okay, I think in the patient, because it's the main actor of the in the patient, and maybe the doctor, because I need to know what is the doctor that treat the patient, some entity about illness, in order to know comorbidities of the patient, and the medical checks or medical revisions about the patient in a specific treatment. For example, liver transplant or the revisions that a patient have after a liver transplant. So
now the person bit is actually relatively simple. Schema.org is all person, and I think they've got professionals and stuff like that. However, when you're talking about a specific area like health or like robotics, then you need to look online to find the relevant ontologies to work out, what do the professionals actually call one of these. I might talk about a heart attack, but they would talk about a myocardial infarction or something like that. And you work out, what? Yeah, because they're speaking Latin, and we've got to work out what we're doing. So anyway, that was just a little exercise to try and get you thinking about models. So I think you can leave the stage now, or we can kick you off the stage. I'm not sure how it works. And I can actually start off with my the main part of my presentation. So the usual question, sorry about this, but can you see my screen?
No, we can't.
You can't see my screen, so I've got to share again.
Yes.
How about now?
Yes, now we have your
Now
screen.
you can, right, okay, let's get going. Where are we? It's that one. So here is a useful set of links before we get started. This is mainly for review after the presentation. We're going to cover most of these anyway. Obviously, latest NGSI-LD specification is basically the subject which I'm going to be doing for the next hour and a half. But if you want, it's relatively dry. It's a specification. What do you expect? So if you want to get a more interactive viewpoint about what you're dealing with, then you should go into the NGSI-LD tutorials. If you all click on that link right now, if someone could put that in the chat, NGSI-LD tutorials, read the docs.io, you can download a series of exercises and follow what's going on. So there are, I believe, something like 27 or 30 operations within NGSI. Some of them are more obscure than others, things like defining the number of types you've got within your system. However, you will find that there is a Swagger specification which will enable you to get various endpoints and you'll see what you're missing. Vast majority of systems, you just need to deal with CRUD. And then on top of that, having got context entities in your system, you probably want to set up a few subscriptions. But there's a lot more, and I'm going to be dealing with a lot more as most of this today. The basic operations, as I said, covered in our videos, covered in the tutorials. Go through that information and so on and so forth. There is a couple of links at the bottom, particularly about modelling. Now, the Smart Data Models has got a pragmatist's viewpoint on modelling, and it comes up with some rules which you shouldn't break, and then at the end, it's like the English language. If you know how to break things properly, you can break whatever you like. However, the ontologist's viewpoint comes on the semantic modelling with NGSI-LD white paper, which says if you are to push your data through a system, this is the way you should do it. Take both of these as opinionated and read through them as necessary. Some of the guidelines make an awful lot of sense. If you want to get a model for data exchange, it must be common. A model for data exchange which is common must be easy to use for multiple users. So things like using common names of attributes in English is probably a good move. At least for your URIs, the name should be in English. Obviously, within your own local system, you can call a temperature temperatura. Nothing wrong with that. It's just that the URI is probably going to be to a well-known organization like Saref. Be Saref temperature, or be a IIT.schema.org temperature, and that's likely to be in English, and so on and so forth. Let's move on to actually doing a little bit of NGSI-LD, and you should be aware of how NGSI-LD requests and responses are defined. Now, obviously, there's stuff which goes in the headers and there's stuff which goes in the body, and the body is always going to be the actual context. So anything beyond the actual context needs to be separated out, and it needs to be placed as a HTTP header. Where possible, the NGSI-LD specification uses the standards of HTTP to define headers. However, there are certain elements beyond standard HTTP which tend to get given a prefix NGSI-LD dash, which would enable or facilitate additional functions. So the first thing which you will come across as a good way of breaking your system, if you are using NGSI v2 or using NGSI-LD, is the file service path headers. Because if you provide a header when you upload your context, and then you don't provide it again when you are retrieving the context, you can't find it. Now, within the tutorial, the NGSI-LD Smart Farm is using a tenant or a equivalent of the fireware service path called OpenIoT. But it's the idea here is that you can have a context broker which is able to separate data from one tenant to another. Tenant being like, I'm a user of this system. Like I'm farm A and I've got 50 cows, and farm B has got 5,000 cows, but we don't want to mix these data up. I've got my data under one tenant, and she's got her data under another tenant. That's great, not a problem at all. It's frequently required for legal reasons. You can't go around mixing mixing different clients' data, not people's data, different clients' data. If you've got to make sure that they can't inadvertently access it by mistake, and so on and so forth. Obviously, you would normally add some sort of authentication in front of this, but that is not part of context brokers. That is part of the security stuff, which is I4 Trust, blah, blah, blah. The thing to remember here is that context brokers are implicitly multi-tenant, and there is currently an equivalent to the Fireware service header called NGSI-LD tenant. There probably will eventually be another equivalent to the service path header. Service path is how to logically separate your data, so it can help with dividing your city into parks which have got certain gardens which have got certain flower beds in them, so that you can make queries over a partial scope of the data. It's not frequently used, but again, you can get lost if you start using this. So the thing which I would suggest is that if you have an NGSI-LD system, I would personally make NGSI-LD tenant mandatory in all your requests, and I would always set it to something, because that way you've definitely got a specified tenant. If you want to, you can just use the default blank tenant, which means that you've got the original database in there. But this is a good way to forget where your data is. Content type header. Always remember the difference between content type and accept. Content type is what is in the body. The body is going to be one of two things. It's either going to be JSON or it's going to be JSON-LD. In that the difference between a body which is just a lump of JSON is that it cannot have an @context element within it. A body which has got LD plus JSON, which is the standard MIME type for JSON-LD, must have an @context type attribute in there. You can see on the right of the screen that I am in this case explicitly putting in the two context files which I mentioned earlier, because that way the data I'm putting in, or the data I'm trying to get out, is a valid JSON-LD. Now, it is probably easier to use the link header for multiple reasons. Firstly, when I am retrieving the data, I can retrieve, say, I have a link header, it's got multiple elements in it. But I can't do that if I have just provided the data using LD plus JSON. So if I'm trying to retrieve the lower of those two examples, and I had already pushed this as with @context deliberately in my payload, the context broker itself must return either the array which I had originally, if you're coming back as LD plus JSON, or it must generate its own link header to say, okay, temporarily I'm going to offer this header which will hold that @context and the what have you, and it will allow me to read stuff. So in general, add a link header. You can see the definition of a link header. This is again standard HTTP. It is, I think, theoretically possible to have multiple ones, but according to the definition of link header. However, I would heartily recommend you only have one link header. It is always the same link header, and it is always the path to your public server, and it has always got both elements of that at context in it. I would personally put always put the core context as part of my public stuff, because that way, when it is returned as JSON-LD, it is a proper JSON-LD. There are guidelines for JSON-LD, and because NGSI-LD is still a living, growing specification, it actually breaks one of them, which I'll come into a bit later. But generally, you want to deal with things, not strings. So, and you can see you've got a string like John Lennon, fine. But if it would be better if you're saying having enumerated values that you can use an at vocab, which is going to be rather tricky at the moment because that's not currently part of the specification. But there are workarounds. The opposite of the content type, in other words, the body going in, is the accept header, which is the body coming out. Now, you will need to support multiple, potentially support multiple types here. There are 3 ways of doing this at the moment. At the moment, you can do, I want to get back JSON in my payload, in which case, obviously, the at context is returned as a link header, which makes sense. Or I want to get back LD plus JSON as a payload. Now, I wouldn't necessarily have any preference as to which one you would use here, particularly when you're trying to communicate between brokers. But if you want to start thinking about the format of your LD, that's when it starts becoming more interesting, because again, there are 2 main formats here, which are normalized, which is the big fat properties and values and types and what have you payload we saw last week, and there's the key values version. Now, the key values version is very useful for third-party applications which are either not interested in LD, you just want to get a lump of JSON out, or are literally interested in JSON-LD and don't care about NGSI-LD. So you could, for example, have a payload key values, just say, give me the name, the address, and the date of birth of this person. If I don't care about JSON-LD, fine, I could actually use the give me back application/JSON, and it will give me a link header saying, oh, by the way, I've got the following context elements, and you don't care, you can just throw it away. You've still supplied that context in the initial request, because that is required to get the appropriate short names, but the short names I get back are fine. Indeed, what I could do at this point is I could say, okay, I have or someone else has inserted the data with the following long names, common long names. I want to change them. I would use this different at context to do that. One of the exercises does that, and it comes back in, using temperature rather than temperature. Fine, not a problem. The third format is an output-only format, and it's application geo plus JSON, which is the MIME type for GeoJSON, funnily enough, and it's only supported for a subset of types. It is only supported for getting entities and getting subscriptions. Now, this is because typically, although not necessarily the case in your health domain, but typically entities are representing a real thing in the real world, and they have a location. And if you have a location and a series of properties, then GeoJSON is a standard format for GIS systems to be able to display markers on the map. And I've got an example a little bit later on. This obviously means that it's much easier to digest for third-party systems if you say, okay, and I'm getting it out in a standard GeoJSON format. In that particular case, you'll get features and you'll get feature collections. Always remember, you look at all three of those. If something goes wrong, it's going to give you back JSON. Because there is a typically it's going to give you a HTTP error code, which should make sense, but they're rather rather obscure because it uses the full set of them. But more importantly, it'll give you a text saying error message, what the problem is and what happens. So imagine this situation. I have a context broker. I have a registration, and I am, say, talking to an IT agent, and for whatever reason, someone pulls the plug on the IT agent. When I request that device, the context broker will say, "Hey, I haven't got the data in this internally, but I'm told that according to this registration, I can get the data from that IT agent over there." It will attempt to get the data from the IT agent. It will time out. It will return you a 406. It will say the gateway has failed, because that is the standard HTTP message. Not very useful if you don't know fluent HTTP codes. So it will also give you back an error message saying, "I can't do this," and it will give you some more information. There are alternative formats. Just because normalized and key values are mandated doesn't mean that you can't have brokers who may, and not all brokers will do this, support additional content. The example here, these are examples taken from Orion LD. Options X NGSI v2 normalized, X NGSI v2 key values, X compacted. This is going to be useful for connecting to legacy systems. There are elements of the Fireware catalog which don't yet speak NGSI-LD, but they do speak NGSI v2, and you may want to create a subscription in a backward compatible format so that the system in question can say, "Oh yes, I've received this in the format I'm expecting." These custom, as I said, these custom NGSI-LD formats, just because they exist, don't overuse them. Don't assume that the other system will use it. It's just for connection to other microservices. When you're talking about data exchange, when you're talking specifically about moving systems from A to B, then we are talking usually NGSI-LD normalized is the one which I would use for transferring data from A to B. The other formats, you are not transferring quite so much payload, so therefore you are losing information. So the maximalized version is options normalized, which is the default. Okay, so now I have here. Actually, I'll put this. I'll do this a bit later. I have here a GeoJSON request example. If you go to, no, sorry, I'll do it the easy way. Where are we? This is the one I'm looking for. Should have brought this up earlier. You can follow along at home if you want to. Right, where's the chat? Right. I am in the process of transferring this the short-term history tutorial to NGSI-LD. If you go to that particular repository, download the repository and switch to the NGSI-LD. So git branch NGSI-LD. You will get a working system which will give you the smart farm. And it will give you a series of animals on it. That's actually one of the exercises, which is in the practical examples. If indeed it will start off by creating a load of pigs and cows. And what you can do with GeoJSON is you can say, right, I want to be able to display my entities, in my case, pigs, on screen. Now there are multiple switches you can add here. So in this particular case, I've got GeoRel. I'm going to do some geofencing. What elements have got a GeoRel? You've got things like within, transect, near, blah blah blah. And this one is saying within, near, 2,000 meters, in other words, 2 kilometers, and it's got a geometry. The geometry is a point. You can see the coordinates. I have URI encoded the square brackets around that coordinate. Usually when you're doing communications, this will be done automatically, but I've done this deliberately in my curl statement. And I can also apply additional filtering, like the Q parameter. The Q parameter is saying for the type animal, I only want pig, I want the species pig, and I only want pigs who are in calf. So you've got the and stuff. And I just want this as key values. So I don't care about NGSI-LD. Indeed, there is, GeoJSON-LD. I just want to get back GeoJSON. And then I say, okay, my tenant, because I'm obviously a particular farmer, I'm OpenIoT. And then I say, I want this back as GeoJSON. And I then have a prefer header. Prefer, because there is a single MIME type for GeoJSON, which is irrespective of whether it's GeoJSON or GeoJSON-LD. We need to specifically add again, it's an HTTP standard prefer header to say, I want the body of my response to be JSON or JSON-LD. And then, as you'd expect, I would need to put in my link header to get hold of the information. Most of this you can automate. Obviously, when I'm writing up on slides, it's difficult, but when you're actually talking with applications, you can, yes, Manix is right, yeah, I mean checkout, not branch. And what do I get back? Well, if I have that request, I get back a GeoJSON format, and it will consist of a single feature collection because I'm doing a query request. And the single feature collection will have, for each animal, or each entity that has attribute, which fulfills the Q parameter and the GRL parameter or whatever, I will have a feature, and a feature is defined as a series of properties in a geometry, because that's the way that GeoJSON works. And you can see in this particular case, I've just got key values in my properties. That's what that bit back options key values works as in a feature collection. And you can see I've got a female, a pig called Tango, and she's currently somewhere in the middle of Tiergarten. Now, the great thing about this is you can go to literally any GIS system, geographical information system, and it will just accept that as a data format. It's a common data format. So you can see that I can quite easily show another pig. I'm showing Peach the pig, who's also in calf, also nicely on screen, because most of us don't read geometry directly. So GeoJSON is output format only. JSON is an output format only as well, if you think about it, because all the interactions which you need to do with modifying your entities uses the normalized format. So it's just for displaying stuff on screen. It's really rather useful, but in some cases you won't necessarily need to do this. Of course, it could be a subset of your data which is has a location. If you have an attribute which doesn't have a location and you push out GeoJSON, then it will have a location which is null, which is valid, but obviously a location which is null won't display anywhere on screen. Temporal. Again, if you go to that repository and you start running it, you will actually run an optional interface which is available within the NGSI-LD specification for temporal representation of entities. So you can actually have something like, give me the last 5 readings I have. This is giving a context broker, which doesn't have a memory. Of course, this means that you have the ability to track attributes over time, but, and you can see the link on the screen as to how to, which I put in the chat, to get hold of how to get hold of this. You can get information about the whereabouts of an entity which is moving over time. Temporal endpoints are found under temporal entities, temporal/entities, but depending on your broker, you may or may not have it. You may or may not need it. It is a performance hit. It is definitely a file system hit, and I would usually not run this under debug. This is one of the reasons why I'm not running this in my usual fashion of showing a video and typing stuff up myself, in that I can't run this easily on a single system. Also, particularly for Orion LD, you may want to get hold of latest rather than the latest release, because there are some performance improvements which have been recently added into the system. Basically, whenever an attribute changes, a record is placed into a database, and you're able to get hold of additional information. So what would you expect to happen when you got the last 5 states of, in this case, cow number 1? You would get a very, very long file. I mean, this was just getting 5 elements, and it would say these can get very big very, very quickly. You would need to have you get back, the cow itself, the ID, the name, and then for each instance, you would have the value, and this is the normalized version, of course, so it's got property and value in there. You would have the value of that ID. So for the last 5 readings, the legal ID of this particular bull, Beanie the bull, has not changed. So it's going to repeat that 5 times. It's also going to repeat his name 5 times and his sex 5 times, because that's not actually changed. But you will find that there are other elements which are going to be the fast changing stuff, which will be of interest. So imagine you've got a bull who's wearing an animal collar. The location is being updated, and the location is being updated every single time the animal moves. So the coordinates will change. So each of the point coordinates, and you can see that this is going to be you could trace a line string out of this. You will see that they move around. Also, the heart rate would change. Now, you've noticed on screen that every single value I've got in there has got an instance ID. This is mandated by the NGSI-LD specification because the idea here is to allow people to delete individual readings if necessary. I'm not sure how far advanced that is, but that's the reason for having an instance ID. But you also should get an instance ID for properties of properties or relationships of properties. So, for example, if you look at the heart rate, you can see that the heart rate has been provided by this cow collar, but it could be possible to delete or amend that particular element if necessary. The things you really need if you're dealing with temporal is you must have observed that properties of properties, because it is observed that is used for keying the timings by default. Observed that is mandated in the core context. It's one of those special non-reified attributes, and you can, if you are tracking things over time, you should probably find that most of your readings should have a value, a unit code, and observed at. Value, obviously, 16, 52, whatever. Unit code is, again, non-reified, but it is defined from a list of three-letter codes which are defined by the UN CFAC code. Again, the tutorials have got a link to it somewhere, which I'd have to dig out. Might be able to find that during the break. So unit code 5K is beats per minute. Unit code CEL is centigrade. Unit code C62 is unitless, which those are some of the more useful. Most of them are quite obvious, like meter is going to be MTR or CL is centigrade. But the more obscure ones are given a number and a letter, like 5K. But C60, I don't know why it's called C62, but C62 is when you want to have a value from 0 to 1 describing a degree of how full things are, 0 to 100%, basically. And it's very useful for things like silos or waste management, where you've got this concept of I am currently 80% full. Well, yeah, that's giving a value of 0.8 is 0.8 watt. So a unit code, particularly because we're talking about data exchange, is really rather necessary to make your information useful. Obviously, when you're talking about geo properties like the location again is going to be unitless because it's already defined in the GeoJSON type as to what the information is on about. It is possible to make a request on the temporal interface, which is leveraging on data which is not observed. In this particular case, we have cows and bulls, animals, and I want to find out information about the cows only, the females. Now, the sex of the animal, again, the sex of the type, start from the top. Type equals animal. That means I'm using the standard data model animal data model, which makes it easier to describe what the various elements are about. Now, one of the attributes of animal is sex. And you can see I put the deliberately put the %22, which is your quote value, in put the Unicode URI enabled. Was it? Encoded quote marks. This will be done automatically if you're using any ordinary system, but I did it deliberately here. So sex equals female. At the moment, that is a string. I'd love it if it was an at vocab, but it's at the moment it's still a string. And if you have something like sex, which is not being observed, it's not being changing the values over time with supplying and observe that, you need to add in time property. Time property will either be created at or modified at. Created at will give you the first one, so obviously it's not changing much. Whereas modified at isn't strictly speaking what it means. It means when it was modified or its metadata was modified in the context broker. So if I push sex equals female and then push in sex equals female again, then the modified at system attribute will change, and that will be in the part of the time property. So it's not literally when the value was modified, it's when the value or the system attributes or the metadata was modified. Be careful about that. You can use this to get hold of the information. I'll put a couple of additional restrictions here. Last end, I described beforehand, was saying just give me the last 5 readings. There are obviously time range. We'll come onto that in a minute, but this is just restricting the payload. Page size is interesting because, as I said, these things get really large really quickly. So it will limit to returning 2, and it will give you more headers back, which will say what would be coming next. And this is what a temporal response using modified at would look like. As you can see, I've just taken the heart rate here. It's the same as the temporal interface, which doesn't use modified at, but you've got one additional attribute. And you can see that modified at typically isn't that different to observed at, if observed at exists, because you'd expect that there isn't that much of a lag, because something is pushed to the context broker changes it, and you can see the difference there is, what is it, 10 seconds? No, it's 30. That was quite a lot actually. 30 seconds on the observed at. The point is that when you have a slow-moving system like agriculture, I would probably have an animal collar which is supposed to be on the animal for the entire duration of its life. You don't want to keep changing these things. So they need to be very stingy with battery power. And this means that typically they would go to sleep, wait for half an hour or however long the period is, wake up, send something to MQTT, and then immediately go to sleep again because they don't want to have a response. And then eventually the system would read in the data saying, hey, I've got some values for you. and it could be that when the reading was actually taken was a long time ago. It could even you could even get a burst of data saying, here are my last 20 readings. And that only hits the context broker when it hits the context broker. So the modified at is when it hits the context broker. Observed at is what the timestamp is coming in from the device in question. One of the things which you may have come across in your initial exercise trying to work out what your data models are is that you will find that device is probably one of the more used models, for the simple reason that most smart systems rely on retrieving information from the real world somehow, and you'll end up this sort of situation where you have something I want to work on, like my cow, and something which is retrieving the data, like my device. So you can see that it's not that the cow has got all of the attributes. It's the relevant bits which the device is supplying, which are on the cow. You can tell that you've got your data model wrong if you find out that you've got a cow with a battery level. Cows don't have batteries. Cows have heart rate or temperature or what have you, and you should use this relationship here to make sure that you can separate your data, because obviously designing your data models properly means that when I return a temporal interface, I can just get back the information directly about the cow, and I don't care about battery level or I don't know, protocol or what have you. You can tell that it's the wrong entity. Just look at the query parameters, and these are the ones for the pagination options specifically for temporal. We will see that you've got last n page size options and options count. The last n, as I said, usually last 5, blah, blah, blah. Page size is more interesting in that the others start giving you additional headers. The reason why they're not in the data is obviously because the data is just an array, and typically data in to any queries endpoint like temporal entities or entities will be an array. It hasn't got any space to put this additional data in the body, so it has to come in a header. So if I put in that particular query here, which the query I did beforehand, which was this one, give me all cows, it will return various headers in the response, and it uses the, again, HTTP standard content range to say, I have got data from 9 o'clock in the morning on the 26th of April to 20 minutes later or whatever it is. And that will explain what last n actually meant. The options count means that I can work out how many records would I get overall. So again, I'm looking for females. I happen to have 174 females on my farm. Funnily enough, I have dairy cows, and there's not much sense in having as many bulls in my herd as cows, because they tend not to produce much milk. So that's why I have a lot of females. Page size is an echo of what you sent beforehand, saying, yes, I am returning. You requested 2 animals. I am giving you back 2 animals. But as you can see, 2 is lower than 174, so I have more animals I could request. And in this particular case, you have the next page header, which would say, if you place this as the page anchor, you will get cal 004 and cal 005 as the next two parts of your request. You can limit your temporal requests in very much the same fashion as you can limit your geo requests, as you can limit your requests on entity. The full request there in English is, give me the heart rate and location and controlled asset attributes of all devices found within 800 meters of this location, and return all readings between these two times. No, since this time, retrieving two at a time, and blah blah blah. So what have we got there? We have got, obviously, we need to know the type of the device, of the entity. There is a /types endpoint, which means you can work out what these numbers are. Obviously, device is the short name for my system, and I am looking at providing the long URL in the link header bit at the bottom. I want to retrieve this as JSON. I am able to restrict my payload in the same way as I would do for entities by saying attrs. So I just want location and control attrs. I put heart rate in there. There's a mistake on there, isn't there? I should have heart rate in the attrs as well. So that needs to be changed. And then you can do geofencing in the same fashion as you can do geofencing in on entities, which we did about 5 slides beforehand. 800 meters, blah blah blah. Now the timing equivalent is this rel, and it's a range. If I go for application again, there are 2 types here. You can do the I haven't done that one. You can either go for the normalized, is that right? Yes, normalized version, or you can go for the I think it's time properly. I have to check the value here. So there is an equivalent of key values, which I didn't put in that. I didn't put in. Yes, I did. Option temporal values. There we go. Temporal values as opposed to normalized. Normalized will give you the absolute maximum of everything. Temporal values gives you something which is probably more useful in most requests, in that your temporal values will give you a series of attributes. This one has got I was supposed to ask for heart rate, location, and controlled asset. This one has got heart rate, location, and controlled asset. And you can see that each attribute has got, where it's a property, has got a values array, and that array consists of a series of pairs. So you can see that the heart rate was 61 for this particular pig collar at that particular point in time. It was 73 five minutes later because the pig was getting excited. If you have a geo property, again it has values, and as you'd expect, the values are going to be GeoJSON, and the timestamp is a timestamp. Relationships are a little bit different. Relationships are, instead of going to have values, they are going to have objects. And objects are the relationship equivalent of value, and it's got a pig and something else. Well, I've been talking now for about an hour, so I think now's a good time to take a break before I come on to the second half. So I'll give you another 10 minutes, and then we can come back at past. I won't be doing the tables because I really need to get a drink, but I've got a question for you lot whilst you are busy either enjoying your cup of tea or going on the tables and chatting to some random people. And that is, do you have any in-depth questions which I should use at the top of the next section? So this is where I'd normally switch on the adverts and you'd go off and make a cup of tea. I'm going to go off and make a cup of tea. I'll see you back in 10 minutes.
And we're back. Hopefully everybody has a cup of tea.
Right, let's start off with the important questions. Who's just had a cup of coffee? Give us a thumbs up. See if there's anyone in the room. Or are there no coffee drinkers? Okay, so who's British like me and goes for a cup of tea instead? No one. Oh, that's surprising. No one. Oh, make me feel better. Right, welcome to part 2. Again, usual question. Can you still see my screen or not? So can you see my screen? Yes, you can. Looks like it. Temporal values. Let's move on to the next one. Okay, this is one of the things for the smart tourism and smart city people more than anything else. NGSI-LD language maps. There is a concept in JSON-LD where you can have multiple strings associated to a single attribute. And the example I tend to give is of the large square in the centre of Brussels. Now, some of you might know it as Grand Place. Some of you might know it as Grote Markt. Both of them are perfectly valid names for the same place because it's a bilingual part of the country. A large number of local authorities are bilingual or multilingual. You take various regions in Spain; they all speak different languages. They speak different variations on Spanish, or they speak Basque, or all sorts of weird and wonderful things. Same in the United Kingdom; you can speak Welsh or Gaelic, or vast majority of these have got this ability to be a different language. Now, if you look at JSON-LD, JSON-LD has got something like 20 keywords. It's got @ID is a keyword. You use @ID to describe the unique identifier of the identity itself. And there are quotes on screen saying what it is. Now, the equivalent in NGSI-LD is just ID because this is mapped in the core context. Okay. Similarly, type is defined as a fundamental identifier in JSON-LD. And because NGSI-LD grows on JSON-LD, you have a type. Okay, it happens to be the same thing as NGSI v2 types, and it's not changed, but that's where it is. Now, JSON-LD has got this definition for @language, which is used to specify the language for a particular string value. This is specifically just for strings. This particular section is only really going to be useful for when you are usually just retrieving static data. If you have bus stops in Bilbao, they might be in Spanish, they might be in Basque. But they're not going to be changing terribly frequently, and they are just going to be string values. But the string values can be marked up as saying, this is my value in that particular language. You can see instead of a value or a value which is used for ordinary properties, or an object which is used for ordinary relationships, if you set the type to language property, specifically language property, you can have a language map. What you can't have with a language map is a unit code, because they're unitless, but you can have a language map. And the language map is then just an array of elements. What this means is that you can retrieve your language map as if it were a property by just adding in an additional parameter. So as you can see, I am getting the location of vehicle A4567, and I want the street attribute, and I just put lang equals FR, and it will give me back as if it were just a property. This is great for multilingual systems, because language property, typically static value, you don't have any problem returning multiple languages. How do you define lang? Well, it's done in the same way as the accept language header of HTTP, as you'd expect, and therefore it follows the fairly standard rules. You can either have a single preferred language, like English only, or you could have comma separated. A wildcard is actually the fallback default. If I ask for bus stops in Bilbao and I want them back in English, it could give me back whatever it's got. It's not a place where you're going to get English place names. Therefore, it's going to give you back either Spanish or the Basque. Or you could actually use quality ranking, which is saying, give me Swiss French or French. Failing that, give me English. Failing that, give me something else. Now, in theory, if you look at language header, it is possible to give you a 404 if it can't supply the language in question. No one ever does that, because it's really annoying saying, yes, you must guess which language I have to give you. So what every system does give you is it will give you a language in return. Now, if you happen to put one of these language properties and you want to filter it, it will also return which language it received it in. Language maps are limited to simple strings. Do not try and use language maps to map smart tourism over a wider range of models. I noticed that about a quarter of you were dealing with smart tourism. There are already well-defined properties with semantic meaning for internationalization, which have been defined within schema.org, and they should be used in preference to trying to manipulate language map and then say put a URI in there because I want that to relate to another object or something obscure like that. No, don't do that. What you should do, according to proper modeling, is one of multiple things. You can either say, I have an entity, my event is called Bonjour le Monde, and one of the attributes of my entity is that this is in the French language. So I have an in language, which is schema.org, or in language. Then you can make queries of saying, I only want to receive information in German or whatever. Similarly, you can use same as, and again, same as has got a semantic meaning from the schema.org. There are probably equivalents in other ontologies out there. It's just that schema.org is one of the really large ones to start looking for, and common ones to start looking for your data models. They tended to start on things like products and shopping and hotels and things like that, which are available on the internet and can be you can derive meaning from a JSON-LD snippet you can put onto a website. Therefore, they tend not to cover the sort of entities completely which are dealt with in context-driven smart systems. So it's necessary to borrow from schema.org where you can, but augment things like device or animal or whatever elsewhere, because what you want is to take something that's actually in use. But same as is one of their standard attributes, which means that you can have an array of other entities which are equivalent to this entity. And of course, this means you've actually got an array of relationships, because these are obviously going to object type. And the just a minute, what is that doing there? I'm going to get, oh, I've been kicked out. So how much did you lose then? Because I was kicked out for a second. Yeah, we were all there. Right.
We just lost your screen, but it's been a second also.
It's only a second, was it?
Yeah.
Yeah, I could hear some weird beeping. Yeah, you can see. Right. So I'll go back to what I was saying. Okay. So same as is obviously a well-defined.
But you're not currently sharing. You need
I'm not sharing.
share.
Okay.
No.
I need to share again because I lost it. Okay. So share
yes.
screen.
Yeah, now we have you.
Now you got me back again. Okay, well, okay, because it started doing that sort of ringing, beeping thing and I wasn't quite sure what it was doing. Right, so same as is, as I said, it's ontologically valid, and it holds an array, and the array will be an array of relationships, obviously. But you can actually also add in a property of that relationship, metadata, so that you could have multiple languages based on that relationship. Obviously, you could and you would have the event "Hello World" saying it's in language English, but it's much more useful if you can also annotate the French version, the German version, the Spanish version, the what have you, with the equivalent entities. Duplication is not a problem here. The nice thing about doing it this way is that you won't annoy the data modelers by adding too many attributes into your data model. I've got an event, it's got a name and a description, fine, and that's it. It is perfectly possible that I am living in the middle of a monolingual country, and I don't want to. I'm not going to have any events in a foreign language. In which case, in language, same as, would be left as optional. You could even use this sort of thing to say, okay, let's say I have a website. The website could have a link for information in Spanish, information in French, blah, blah, blah. And you could have an array of in language saying it's in either French, German, or whatever, or these URLs and so on and so forth. So you can see how internationalization can be done. And of course, this is vital if you're going into the smart tourism domain. Right, expansion and compaction. There are various libraries which are used in JSON-LD. If you go to the JSON-LD playground, you can online put in a snippet of JSON-LD. You can put in a context and you can play around with it. The snippet of code I have here is just doing a JSON-LD expansion and a JSON-LD compaction with a different context. Now, this is very useful if your short names don't match with my short names, or if I want to extract, let's say I have a cow which has got a string value for the sex, and I want to make it an enumeration. I could do this through an expansion and compaction operation. So it could support vocab elements. So I could have make the gender a URI rather than just a string. You can operate on either normalized or key value payloads, because the payload you get back, provided you've got the context, then is JSON-LD. Obviously, if it's normalized and it's got an at context value in the body, going back to what we were doing before the half hour, with the thing is completely valid. Otherwise, you would need to look into the link header and place, say, my context is. This isn't a particularly complex operation, which is on screen here. You'll have to look in JSON-LD to find out the full level of things you can do. But the idea here is that I, as a independent system, am not forced to use your short names. I am forced to understand what your long names mean, and if I want to have different short names, that's fine. Now, if you have an at graph in your JSON-LD at context, you can say, okay, well, you might. I personally call it schema/name. You might want to call it friend of a friend /name, but actually this is an NGSI-LD system, so we're probably going to end up compromising and saying it's an Etsy/name. But that sort of thing can be used to manipulate your data. When we're talking about data exchange, I'm assuming that the data that's coming from elsewhere is dirty, or needs cleaning somehow, or needs manipulating somehow. And you should think that you might want to just modify your attributes before you strip out stuff you don't need, or start running additional operations over it. So that expansion compaction operation, again, is one of the examples. I think it's the working with linked data example, and I can change my representation relatively easily from what you have on the left, which is an NGSI-LD response, to what you have on the right, which is the same thing written in Japanese, because I put in a different context. Now, the elements I have highlighted in yellow are mandated by NGSI-LD. So therefore, the response I have on the right is valid JSON-LD, but is not valid NGSI-LD. You cannot use Japanese characters for ID or type, because it is defined in the core context of NGSI-LD that ID at ID equals ID. It does not equal whatever those Japanese characters are before building store 5. I could have gone further. I could have changed point to the Japanese equivalent. But if you look at the value of the street address, we have got address, which is a type, property, and value. And you notice that the attributes within the value have not been translated. This is deliberate because my address is defined as a schema.org address. The Japanese characters also define that in their context as a schema.org address. And a schema.org address has an address locality, an address region, and a postcode. That's why you've got the unchanged values on the on the right. Now, it's a rather extreme example because I've done it for internationalization, but you could see how I could change elements if I want to, but I can't directly place these back into my context broker. More realistically, if you are dealing with a subscription, I would get a subscription with a payload, which is a JSON value. I would then use some microservice to actually do something in order to manipulate the data to offer that in another format. I could take a subscription, offer a JSON payload, forward it as a plain text string, that sort of thing. Now, one of the first questions I was asked at the Fireware Bootcamp in Malaga a year and a half ago was, what can we do about getting my street names into alphabetical order? I said, it's fine, it's A to Z. They said, yeah, but we're in Spain and we've got accents over our characters. And therefore, A doesn't follow A with an accent on it doesn't follow A. And at the time, my thought was, if I got a situation like that where I want to collate natural language, I would probably use a database, because that's what databases do. They're able to sort things out. Now, with NGSI-LD, you can't do collation directly, but you can do an awful lot better than NGSI v2 can. So this is going to be about making sure that your data is available in a fashion which you can actually use. Now, there's a reason why things like collation and internationalization and what have you aren't dealt with by the context broker. Context brokers deal with context data. Context data is there for data exchange. So it is important that when I say I'm offering you a string, you know it's going to be a Unicode string. When I'm offering you a date, you know that the format of the date is always going to be an ISO 8601 date, because you don't want to say, here's a date, oh, and it's in French. Because my system might not understand French. It's already defined that it is an ISO 801 date, but if you want to get hold of it in French, that's your problem, not mine. So, okay, typical examples about what you might want to do. I know that I've got my date in a format, so I can then just use some internationalization module. This one's JavaScript, but Java's got them, Python's got one. Yeah, everyone's got these things, because the date format in various different locales is pretty unique. The Americans switch over the month and the year. The names of the days of the week in French are different to the ones in Portuguese. Portuguese nicely numbers them from 1 to 7, very logical, and then so on and so forth. So you don't want that sort of thing inside your context broker. It just adds bloat. It's unnecessary. It's somebody else's problem. So I'm saying context broker doesn't do this. You need to sort it out on the endpoint having received the data. However, you can actually do a reasonable job in collation provided you're only worrying about one language. Now, that rather useful little code there replaces all of the accents in a Unicode string by just stripping them out, because the NFD format is going to give you individual characters plus the accent after it, and that's just the Unicode range will remove those accents, and I'm putting in lowercase. So what this means is I can create a property of the property. I'll call it, let's say my property is called name. I'm going to call the property name collate. And I can add that in to describe the data. Why is this a good idea? Because the problem with pushing it out to a database is that a database is doing precisely the same thing. It slows the damn thing down. It's difficult to get the right format, and frankly, you don't necessarily need to have replacement of umlauts if you're not a system in German. So you can just say, okay, for my data, when I'm putting it in, I will be careful with the collation, make sure there's make sure there's property on there. You could, if you wanted to, again say, okay, let's create a subscription on name, and then when name is updated, update the metadata of that name attribute. The German way of doing it, again, quite simple. You just umlaut is replaced by the letter E after the letter, so why not replace it, put it lowercase? This means that you can obviously query for your collation and quite nicely get use a regex qualifier for I would like everything starting with the letter A, and it will do it without prejudice for accent or anything like that. If you want more than that and you really want the full-blown details of a database, then you're probably going to have to go for a database. Okay, context broker anti-patterns. What context broker don't do at all. I was going on about collation support. You can do it if necessary, but the thing that you shouldn't think that a context broker does necessarily hold all of your data or all of your inputs, let's put it, rather than data. Context data is just data. It doesn't deal with things like blob types or file systems or short-term predictions or whatever very easily. What you need to think about is that there needs to be other ancillary systems which can be linked to using URLs or queries or whatever to get hold of the information you're after. So let's say I have a system where I'm taking number plates and I want to register the cars passing through. The actual images aren't context. The actual images are raw JPEGs, let's say. I can't deal with that. You need to get an interpreter on that to extract the number plate. The number plate passing through is my context data. Now, it might be relevant to store the image because I'm big speed cameras or something like that. In which case, the way to do that is to have a storage system which stores the raw data, and the location of that stored data is the attribute. Why? Because one, we don't want our payloads to be too large. Two, we only want them to be up there. Being an image, it's likely to be static data, so we don't need to worry about that. In this case, if you want to have changing images, then you'd have an attribute which is changing, which is what we want to do. Short-term predictions. The two I split up predictions into two parts here because I can see a temporal difference between the traffic will get worse in half an hour and give me the prediction of the traffic, because it could be the case that you want to base your prediction on current scenario, in which case you can't put the future directly into a context broker. No one knows what's literally happening in 5 minutes. But what you can do here is I could have, based on the entity, I could have a URL which would say, use this link to work out what the future will hold. And that link could potentially say hold the entity ID. And I'd pass the entity ID and the value, and it would say take out my location. It would ask my database, based on the 5 buses in front of me, am I going to have a nice run? Is it going to be quick? Based on some third-party traffic system, do we believe that things are going to slow down? And then that URL could give me data back. It's an on-demand prediction as to what is happening, and that has to be a URL, because otherwise, every single time you need to poll and update this short-term prediction all the time, which is not particularly useful. Creating medium-term predictions is a bit different, because this is where I would consider using things like artificial intelligence to work out, at some point in the future, we believe that this cow is going to go lame. The way to look at this is that I can periodically make a check. According to our current system, this may be a problem in the future. I can periodically make a check, which I want to do based on our current context plus our machine learning plus whatever the third party is. So in this case, the cow has not been moving so much, so I reckon it's probably going to be need to be looked at. In that case, what I can do is I could have a subscription, and the subscription would or a cron job, depending on what's changing, could just say, okay, every day, why don't I run a long complex calculation, and then I would add another attribute for my onto the system based on the results of my calculations. So it isn't the context broker that holds this information. It is provided by the third party, or either as a URL, or if it's a less time critical system, it can be put onto as an additional attribute if necessary. The real work in this calculation, as it states, is done by the microservice. You can't actually put it, the context broker is dumb, it just got whatever the data actually holds. Right, let's move to the next section. Filtering. There are multiple ways you can filter your data. As you can see if you look in the NGSI-LD tutorials code, there's a concept of I have a store. The store has shelves on it. The shelves are stocked with various different products. I want to sell beer, and as my beer depletes, the status of the store changes and I potentially want to raise a subscription because I've run out of beer. Now, in order to do this, when we are navigating the knowledge graph, we do not need to get the full entity in all cases. You know, I want to get hold of all the shelf. I want to get hold of the stocks and number of items attributes of all the shelves within this set of IDs. That's all I want. I just want a list of IDs. I don't want too much information. You don't want to download every single shelf and then manually filter the list of IDs. No, that's what your context broker should do. So you should consider looking at minimizing the payload when you are navigating stuff. Obviously, types is a comma separated type. Sorry, in this in list entities is a comma separated list. So obviously, rather than get all my my buildings or people or what have you, I've got type shelf. Okay, it could be small shelf, comma big shelf, comma whatever, wherever other things are. Attrs again should be readily identifiable from your data model as to which ones you want to have here. My thing stocks in this particular case, you know, what does this shelf stock, is actually a relationship. So it's I'd want to get hold of the next product. Yeah, I'm going to product in this case, product in the product list. But ID is not necessarily the right attribute. It's not really an attribute. It's the ID of the entity. It's not necessarily the right part of the data to use for keying your system. Simply because the ID is only guaranteed within your own broker federation. You know, I have a context broker or a phalanx of multiple context brokers who are exchanging data between themselves internally in my stuff, and we have a well-known URL URI for this entity. In the case where we're talking about data sharing, which is very much what the whole point of this exercise is, I have no control over your system. I have no control of your IDs. So in the case where I have animals on my farm and you have animals, the same animals in the your veterinary practice, I can't guarantee that the ID which you hold is the same as the ID I hold. There is a reason why data models potentially have attributes like legal ID, because that way you can deal with entities in common. If in this case, if I was trying to do with a legal ID, I'd use the Q parameter, where legal ID equals blah blah blah, or legal ID equals X, comma Y, comma Z, comma whatever, to be the various different properties. So don't consider that ID is necessarily what you want, but in many cases it should be sufficient. Obviously, this is a linked data system, so where I'm talking about shelf, I'm actually talking about http://fireware tutorial /data models /shelf, which will be very difficult to type, let alone say. And therefore, the reason why shelf works is only because I have defined this in my actual core context. So when I'm doing this navigation, which is going from one entity to another, I can just use this key values stuff, because key values has got sufficient, will return me sufficient information to give me the necessary data so I can make the next query in the chain. Obviously, when I'm talking about data exchange between the vet and the farm, I want normalized. Normalized is going to give me the full information and I can also verify that it's my cow. Or, I can update my data to match your data, and so on and so forth. Filtering using the Q parameter. This is one of the more powerful parts of using the context broker, and it's got the full. I've got the full list there. Most of these are relatively obvious, but equal, unequal, fine, greater than, less than, equal, not a problem. But thing you need to remember is that you can. Chain multiple predicates together using and or. And is a semicolon, because obviously the and character in HTTP is problematic, and or is a pipe. In order to keep the calculations within context brokers simple, you have to provide the function ordering. So in the case where you've got the first one where a speed greater than 50 RPM 3000 brand name Mercedes, is that going to be, which one's going to come first, the or the and? Well, let's not overburden things here. You are a developer. Use some brackets to point out which ordering it's going to be, because that makes the parsing of the tree simple enough. With obviously brand name Mercedes or whatever, you could just as easily use a language map as a string. And again, you could even say, and the German name of this is Opel Kadett, whereas the UK English equivalent of an Opel Kadett is a Vauxhall, for example. So that would be supported as well. The second and third lines are actually equivalent, and the double dot is used for range operations. This obviously can keep your queries simpler. So temperature range from 20 to 25 is the same as temperature equals or greater than 20 and 25. Obviously, the or operation will change. You can make queries on sub-attributes of a value. So again, if you've got an address and you know the address has got a city attribute, you can use that in the query. Within your strings, you can URL encode them. So in this particular case, I put the lowercase u with umlaut in URL encoding. As mentioned earlier, it may be better to have an additional property for strings, or look on a different metadata value of equivalent of that address, if that's relevant for your query. There is a difference between the V2 and the LD syntax here, in that the dot, temperature dot observed at, will give you the property of a property or relationship of a property, whereas the square bracket will give you the sub-attribute of a value. Finally, you can very frequently use commas to look for elements within an array, in the same way as you can say either ID equals X, Y, or Z. You can say the category of my building is barn, farm, auxiliary, field, or whatever. You need to ideally, in all cases, you should narrow down the area of the knowledge graph you're considering as much as possible, as quickly as possible, because obviously the more requests you need to make, the better, the bigger the load on the system. However, because we are not talking about databases, it is possible to, if necessary, duplicate stuff so that we can look at it within my entity rather than your entity. The equivalent for geofencing is a little bit simpler, in that you've only got the options near within, contains, intersects, equals, disjoint, and overlaps, which are obviously fairly obvious. They're concepts you can get from basic geometry. Coordinates usually need to be, you may need to URL encode the square brackets, but again, it's just an array or an array of arrays. And the additional value, the additional parameter geoproperty, is if you want to be checking something other than location. I would always use location, to be perfectly honest, because most places literally just have a location, and it's much easier to use for geofencing queries, or indeed geofence. All of this, which I've just described, is also relevant for subscriptions, because obviously you want your subscription only to fire if my cow has escaped my field, or whatever. Temporal parameters, even shorter list than geofencing. We mentioned last then, but you've got time before, time at, end time at, and either before, after, or between. Default is obviously going to be observed at, but you now need to look at the system, your system yourself. Right. Before I move on to the next exercise, no, actually, no. I'll give you this exercise. Let's move on to that. So we're coming to the home stretch. Okay. So this is my system. I want to imagine the following scenario: a farm has pigs and cows tracked with animal collars. Veterinary practice holds status records for the same pigs and cows. Weather service can provide detailed weather conditions for location of the farm. And I've got 4 questions. So again, I would like you to break out onto the tables again and try and work out what you see as the various elements in this system which you want to separate into your various different context brokers. So again, this gives me a chance to stop talking for a couple of minutes. So can we come back in 3 minutes? Go back to the tables, talk amongst yourselves, and say, based on this scenario, how would you expect the system to be split up, and how you'd expect to connect it together? Because this is going to be the what I'm going to cover with my sample for the next 20 minutes. Can you see my screen now?
Yes, we can see your screen.
Okay, well, that was obviously quite a simple little exercise, but I hope you've come up with the same sort of answer as I have, because this is fundamental to what we're going to be doing as I4 Trust. Is that we've got 3 obvious data providers. We've got we've got 2 obvious data providers, and we've got the farmer. The farmer is central to this system. So the farmer is going to be grabbing hold of information, and I would want to be using data from the various different sources. Right, where are we? Go on. That one. These are the data models I would actually be, I personally would be using. You may have others. There's no requirement to be using the smart data models. It's just that they happen to have a large number of models which are relevant for the agri domain. So obviously, if I'm talking about here, I have pigs and cows. Pigs and cows, animal collar. Animal. This is also going to be necessary for the sharing of data between farmer and vet, because I have a definition of animal. They should have hopefully the same definition of animal, or at least a definition of animal I can actually read from. They have the status record of the same pigs and cows. Now, it's possible they have a different one, but not maybe not. Now, the Weather Service is obviously someone else. So I'm going myself. Pigs and cows tracked with animal collars. Tracked with animal collars means that the animal collar is going to be a data model based around device. However, device is not necessarily going to hold or have well defined within it all of the elements which are required for an animal collar. It might not. Location might not be. Actually, location is in there, but each minute isn't. So I would need to extend device with optional attributes so that I could actually rate that. Now, the way I would deal with this is that I would have a provided by relationship onto the animal itself, so that I could actually get the information coming through. Now, I would also want to find out Weather Service providing detailed locations on the farm. An animal is not going to have a weather. It doesn't make any logical sense. But you're much more likely to have information about an agri-parcel, a field, and then that potentially could be connected to the weather. Retrieving weather from a third party, I would probably follow whatever their weather model was. And again, in this particular case, we've probably got weather observed because it's just coming back from the Weather Service. Now, let's extend our animal. The animal is going to be getting information from the vet. Okay, so the rate of growth of the animal, or whether the animal is in calf or active or whatever, are going to be retrieved from the vet, and this is information I would like to have within my own farm system. I would buy off my third-party provider. They would obviously give me regular updates as to the condition of my my animals. So I need to have a globally shared ID for the system to work. Because I want to get hold of the information about the cow called Twilight, and I can't rely on the name being unique. I can't rely on the ID within my system being the same as the ID within their system. There is a government mandated way of being able to track this information, and we can use that common value to be able to get hold of the necessary information. Meanwhile, for the weather conditions, there is within the weather conditions, within the animal model, there is an attribute called located at. This is not location, it's located at. And if you look at the definition of located at, it's an agri-parcel. It's going to be, my cow is currently standing in the north field. Okay, now the cow can't have weather conditions, but it would be legitimate for there to be properties of that weather conditions, of that located at to properties of the property, of that located at to hold information about current weather. So I can currently see that my cow is being rained on, which is useful because I would want to make additional information based on this augmented context. So this is how I would set up Animal to be able to get hold of the relevant information. But then we still have the fundamental issue. The fundamental issue is that I don't own the vet information. I don't own the weather station information, and I've got to somehow get this into my system, or available within my system. Am I going to do this subscription? Am I going to do this using registrations? What are you going to expect? So it will depend, and this is the nice thing about any powered by fireware system, NGSI-LD, is that it will depend very much on your use case. So let's look at option one. Option one is we have this common agreed identifier. The common agreed identifier I can find on my animal model. Okay, so what can I do? Well, I can have, say, for example, a patch request. I can put patch request onto cow6 to saying, refresh my vet data. I would then have an attribute which I would be watching with a subscription. Watching on the subscription, I could then say, okay, right, notify me of veterinary requests. This would be going towards a watched attributes has got the wrong thing in it. It should be refresh vet data. Oops. Yeah, so there's a mistake there. So I'm watching the animal entities, and my watched attribute should be the refresh vet attribute. Got that wrong. And then I would retrieve back into my notification, my subscription notification, saying I would have a payload which consists of the legal ID of the cow and whatever I put into refresh vet data. Now, in this particular case, I want to refresh the phenological condition and reproductive condition. You can then see, okay, I've now got some information. I might need to have, because I already have a relationship with this this veterinary practice, a business relationship, I can then just send a request direct onto their context broker with my token saying, I am Farmer Jones, and I can then retrieve back information. So I'm just going to be doing a simple get request, and then I will retrieve back, what I've requested. Fine. If they are also using the animal model, this is very simple because we can then say, okay, this is one of that, this is one of that. It might be more difficult if if they've got different attribute names. Well, in that case, my request to the vet would have a different context. So if they want to call it change phenological condition to something else, I can still use these actors in my request because I'm saying, according to my context, it's this full long URL. So I might need to, I might retrieve back their information. It might need some sort of logic. I would then need to end up doing an upsert back into my cow to say Twilight is now a female adult, or Twilight is now an active adult, or whatever. So you can see how the information could get in there. Option 2. Option 2 is a little bit more difficult in that, as I said, cows don't have weather, but you might need to associate a third party into your context data, so you have the flexibility to get hold of information from a variety of external sources. So I have a field agriparcel. The idea is not unique to me, but it's not unique to them. And of course, remember, I could even have a system holding multiple farmers and multiple farmers' fields. I could have my tenant be using my tenant in there as well. Now, what I could do is I could say, well, looking at agriparcel, there is a related source attribute defined, saying what other external systems are related to this field. So I can then legitimately place into related source an application ID and the application itself, saying it's an agri app or whatever. And it would be an ideal place to put my weather conditions, because if you think about it, a field, it is raining on a field, is a rather than saying a cow is raining, it is raining on the north field. Makes sense. So I could add my weather conditions onto agriparcel. It's not required to have the full weather conditions on the animals, probably, but you can foresee a situation where you might want to end up duplicating this data. So how are we going to get hold of the weather forecast? Well, it's a little bit more complicated. A little bit more complicated in that what I would do is I would find that, you know, I would probably do something like I would make a request direct to the weather forecast, saying I want to get hold of update this. And again, I could have an entity agricultural weather app, which would be used to trigger this notification. If you can see, according to the agriparcel, this is my related source. My related source is that URN. So I can say that URN is saying this is what I will use to get hold of external weather. I might want to do the weather on a cron job, or I might want to deliberately send a patch request to get hold of external context. The concept of using a patch to do stuff is effectively the fireware way of standing above device platforms. We don't care whether you are, say, activating a device in the field using MQTT and a JSON payload, or whether you're sending out a little gremlin to turn on attack themselves. It's just a standard method of patch, go off and do something. In this particular case, I'm saying whether go off and notify me of weather requests. But you can see that I could just as easily have said, okay, I want to do this from a dashboard. My dashboard would follow me across the farm, and I could show the various location of the fields, and I say, okay, I need to get a new weather forecast for that. And then the business logic of the dashboard could be said, right, get hold of the current field, find out what its related source is. In other words, navigate the knowledge graph to come through and find out where are we going next. Find out, is it going to be obtaining the weather information from a weather station, or is it going to be getting it from an external system or what have you? So we've got sufficient information to be able to make this request. Now, in this particular case, I'm doing a request using a patch. I'm just and this is just saying, you know, change my current situation. And once again, you have an endpoint for a microservice, which can then cut in between the get data from somewhere else to do the necessary stuff to be able to successfully get hold of the information from my weather service. There will need to be some negotiation. Maybe I need to make a credit card payment, whatever it happens to be. But you can see in both cases, I am suggesting that the way to be able to do this is to create a microservice which is receiving sufficient information on the trigger to be able to do the necessary stuff. And then within that element, we would have additional business logic to upsert the data back into the system. Now, in this particular case, because I'm doing this on a field level, but I want to deliberately get some data into animal, I'm going to have to be quite clever and say, right, when I retrieve my response, update agriparcel. It's raining in the North Field. And then because I want to have this information on easily accessible animal, it's update the metadata of the animal to say it is currently sunny in the located app location of whatever, because you don't necessarily need to have the full weather conditions on the animal. Only reason I'm putting on an animal in the first place is that I want to have easy access to that attribute. Imagine you've got a weather station. It's got rain, it's got temperature, it's got pressure, it's got a description of whether it's sunny, it's got wind speed, it's got all sorts of different things. Imagine a situation where you are trying to predict lameness of cattle, and you have realized that you can tell whether animals are having difficulty because they're moving less. There could be additional reasons for moving less. I don't know about you, but I don't like walking the dog in the rain. And presumably the cow doesn't like wandering around the field in the middle of a storm. It will stay put and shelter for a while. So, okay, in this particular situation, what I'm after is a historical record, not only of where has the cow been, but I want to know where that particular cow, what were the weather conditions affecting that particular cow, because that is relevant for my machine learning model. Obviously, I'm not going to flag a cow as being potentially needing an expensive visit from the vet if all it's been doing is just sheltering from the rain. So in that case, I need to have a historic record of where is my what has happened to my cow. So therefore, I need to have a I'm lost again. Right, did you lose me for a second?
Yes, and we lost your screen, so you're currently not sharing.
I'd like to know why it does that. Yeah, so I was waxing lyrical about my farm, wasn't I? Because cows can move around in different places, I can't rely on the fact that the cow is not currently in the North Field to say it was always in the North Field. I need to have historical record. I therefore need to have some sort of weather conditions on my cow directly. Now, obviously, it's not going to be an attribute of the cow because the cow is not raining, but it can be legitimately be a property of a property. Second level properties are available on the temporal interface, as I showed in the first half. So it would be possible to extract that information and make legitimate predictions about it. On a more practical viewpoint, what's the point of all this? Well, you and I may be looking at a cow, but a farmer is looking at 700 euros of profit, and it's worthwhile potentially buying a system based on the I4 Trust to get hold of this system and protect your system. Right. So I want to ask you to do another little exercise here. Now, could I get a quick hands up from various people? Raise hands. You look at the hands raised. How many people here have already passed the examination to become a fireware expert? Could we get a quick show of hands? We've got one raised hand there. I'm sure we've got more. I'll start picking on you if you don't put. I can see some more. See, who's got the raised hands? Oh, okay. Various people are doing emoticon. We need to do the raised hand thing as well. How many people here? And they can just do the emoticons this time. You can put your hands down if you want to. How many people here are looking to be taking the examination in the near future? We've got a few people here now. I suggest it would be a very good exercise for, and I'll put it. Where is it? Documentation. If we do a very quick, 10-minute probably, mock examination series. So what I suggest we do is, I'm going to do the live chat, is that we do another breakout. And I would like that the various people who've already signed up, already been certified as fireware experts, sit on separate tables, and then other people can be asked questions from, and we'll start off with the NGSI interfaces questions, a series of questions on the NGSI interfaces to find out what the level of answer your potential candidate has got at the moment, and then you can swap over the same question so that we could ask to pick a random random attendee expert like Daniel Villalba. What was the answer I gave for that sort of question? So we can actually work out whether you've got the sort of, you'll have some understanding about the sort of level you will need to have for that particular examination. So I've put the list of sample questions on the chat. So that you can download and have a look at it. Let's break out for another 10 minutes so that various people can get quizzed about what the questions are, and then we'll come back and I'll ask some more questions for the group as a whole.
And we're back. We don't have your screen, Jason.
Yeah, there's not much left. Right, yeah. You should now get the screen back again. I hope that was instructive. It's always useful to know what you're letting yourself in for, and you should have some idea. Hopefully, if you're looking at the questions from section 2, what are subscriptions used for? Well, should have some vague idea about what a subscription is used for by now, or what's the point of metadata. Having been through this system, and hopefully from the people who've already been through it, they'll be able to tell you what sort of level of answer we're looking at. But the main reason for covering that one, and I don't know how many of you actually got down to the question. It's something like question 16 out of 20. Is what are registrations used for? How do registrations work? And why? And give a practical example. Because as you probably noticed, so far I've been talking purely about doing this subscription stuff. Now, if you look at the documentation on IoT agents, the way I've described this so far is what is described there as a bidirectional attribute. In that it's using a subscription to monitor what's going on, and it then does whatever it needs to do in the real world. You can get the same thing with devices. You can effectively push a value down into a device, but the default for devices is using registrations. So why haven't I been talking about registrations so far? Well, I'll move that one there. That's the one I need next. There we go. There. Yep. Okay. Now the thing about the way I've described it, I've described using the subscriptions. Okay. Registrations are only really useful within your own context broker, or within your own federation of your context brokers. You at the moment would have great difficulties trying to get a device connected to a federation, because federation implies that I'm a full context broker. I'm willing to pool my resources with you. Well, we're not pooling our resources here, are we? What we're actually doing is we are getting hold of information from third parties, so we need to push into our systems. So effectively, we're using subscriptions for a degree of actuation. Usually, you would use registrations for getting hold of information from third parties, but that third party is going to be really, really trusted. And what we're not doing here is trusting people properly. The other point, I've got the slides the wrong way around this way, was talking about how to use your models. The models, strictly speaking, animal shouldn't have a weather conditions. You could get all the information from located at, but it is important that your data is usable. It's more important that your data is usable than it is ontologically correct. And if it is simpler for you to get hold of the information by upserting into your animal entity, I would say update your animal entity. And that was the last exercise I wanted to get done for this session. So I've got a very short period left for people to ask any questions directly, or, of course, they can do the old-fashioned way of actually contacting me via either LinkedIn or Fireword. So I'll just put my contact details onto the chat whilst I open it up for any questions. Just a minute. Oh, I'll go that way. Find out who I am. Use that one. There's a direct. What's the direct there? Message requests. Okay. Wrong one. That's the one. Right. So, do we have any? That's what I want. View profile. So, do we have any direct questions whilst I'm still online? Or what I will do is I'll put this into the chat, live chat. Is I will put my LinkedIn details onto the chat. You can always ask me either questions via messaging or details there. So if there's anyone who's had difficulty with working out what's going on, the questions are in the questions section. Okay, that probably helps. I'll start from the top. I was looking on the chat rather than questions. Fine. Option 1, the patch mechanism. I am missing the patch value. Yeah. How do you provide the female adult part? Okay, for the patch, the example, I'll go back to that. Bink, 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 bim. What I'm doing here is I'm requesting a refresh of the following vets data. So what? And actually, the watched attributes is still saying filling. It should. Oops. Filling, it should say watch attribute is the refresh vet data, so that you would be able to pass in to the microservice the saying I would like to get hold of the phenological condition and reproductive condition, which is what in the value of the legal ID of this particular cow. So that would hopefully fit in. Okay, how's it going to solve LD the use of service path v2? When the ETSI committee come to consensus, the specification gets updated and it will say more stuff. At the moment, that has not been a priority for ETSI to complete, therefore it's not been placed in there. So the answer is when it is considered a priority by the ETSI committee or the members of ETSI. At the moment, it's not there. You're quite right. So, essentially, for internationalization, we create a copy of the same language and in use as blah blah blah. What's the way to go for updates? Do you update each entity or store the property in the main language? I would say that an event in French is a separate entity to an event in English. So if you have a walking tour which is starting at 12 o'clock, and there's one in French and one in English, and then you decide to move it to 12:15, I would update both entities. Remember that the basic model is a model which is language agnostic. So you consider the situation where you only have the one language. It's going to be update each entity. How to query temporal values between two timestamps. That I think I had an example of earlier. There we go. The lower one there, it's got time rel between. And it's obviously an ISO date stamp. I actually did from 9 o'clock in the morning till 20 past 2 or whatever. Yeah, that's right. And it's if you look at the time roll there, this is actually the duration of the I4 Trust trainers. Between those two times, you should be learning more about NGSI. Okay, next question. How to make NGSI-LD 10 mandatory in a header with a proxy? If you well, there are two ways you can do this. One, you could have an empty default tenant, so you get no data back. But if you want to make a header mandatory, that's going to be down to your pet proxy or something like that to say you need to do this, you need to do that. So therefore, you could have a service in protecting your context broker, and one of the things it checks for is that there is a tenant. Obviously, if you look for data for a tenant that doesn't exist, it will return an error. If you look for the default tenant, there's nothing there, it will return a 404. So you just need to put it into the request. And then I think this is the last question to try and get the time. What happens if we change the location of the context file to another domain? How do we update that information on every created entity? Well, every created entity has actually not got your short names, it's all got your long names. So your long names are the real source of truth. So you have updated a location to be an Etsy URL location, and then if you change it to try and be something else, then all the context data you've put in already is referring to something different, isn't it? So you might want to, if you really want to change something because you've got it completely wrong, you'd have to do an operation like retrieve the current attribute using the old context data and then update with a new value using the new one. So it would have to be an iterative process. So how are we doing for time? I think that's probably about it, isn't it? Yes, we're slightly over time, aren't we? So if there's any further questions, you can either do the questions quickly now, or you can contact me later, or indeed, I've got the next session, I think, in about a week's time.
Yes, we have the Q&A session on Friday, actually, and there's the technical part and the business part, so they can also bring their questions on Friday, and they can also contact you or any of the speakers via Spaces as well.
So I hope you learned something this morning. If not, I hope you've been entertained. And I'll be back next week, or later on this week, sorry.
Yes, thank you, Jason, and thank you, everybody.